This is our first video in our kinematics series for GCSE Further Mathematics. Kinematics is the study of the motion of a body or object. So we will be looking first of all at displacement time graphs. I'm going to jump to those notes there. And so that's what we're going to start with, and then next video we'll be looking at velocity time graphs. So displacement time graphs. A displacement time graph shows how the distance of an object from a set of points changes over time. The horizontal axis is always time and the vertical is always displacement. And don't forget to include the units. Okay, let's just look at this example and we'll explain what is happening in this example. So it's displacement. Now what it said in the notes above there, which we didn't go through, was displacement is distance and direction together. So it's distance in a given direction. So here, if you can see what's happening here, the body in the first 5 seconds, the body moves and it goes 10 meters. And we're going to assume this direction is a positive direction. And then from here to here, it's at positive 4 meters. And then it comes back, so back to where it started, and then back another 4 meters in the other direction. So the displacement up this way, you can see up at this point, is positive 4, whereas down here the displacement is negative 4. So this negative 4 means it's 4 meters in the other direction from this one. So you've gone up 4 meters here, and then you've gone back 4 meters in the other direction for this bit. Okay, right, we're going to look at this question. We're going to look at this question and see what we can do. So it says here, calculate the velocities of each section of the displacement. I'm just going to change my question a wee bit. I'm going to write down, call this point here, call this point A, call this point B, and call this point C, and we'll call this, it's already labeled as O, we'll just call it O as well. Right. I'm going to just look at the sections from O to A and think about what is happening. So in this section from O to A, we want to find, it says calculate the velocities. So the velocity, and this basically is just, to find the velocity, you're just finding the gradient. So the gradient is your vertical change over your horizontal change, or you may remember as rise over run. So the rise, I've gone 4 up, and my run was 5. And if you do 4 divided by 5, you're going to get 0.8 meters per second. Just on that, the units meters per second can also be written as ms to the minus 1. So meters per second could also be written as ms to the power of minus 1. Right, that was first wee section. The next section was from A to B, so from here down to here. So my velocity, and it's going to be a negative velocity here because it's going back in the up. If this is a positive velocity going this way, then going the other way is going to be a negative velocity. And my velocity, my rise is minus 8 this time, and I've done this in 5 seconds. So how it's 5 seconds, from 5 seconds up to 10 seconds. And if you do that, minus 8 divided by 5, you'll get minus 1.5 meters per second. Okay, from B to C then, the final bit that we have to do, we're going to look at our velocity. So let's think about what's happening in this graph. At the point B, my displacement is minus 4. Here, my displacement is minus 4. On along a wee bit here, my displacement is minus 4. And point C, my displacement is minus 4. So basically, it hasn't moved. So if it hasn't moved, it is static, it is stationary, whatever we want to say. And if you're stationary, your velocity is 0. So 0 meters per second. So what you need to realize here is what it says up above here, a horizontal line. So let's just highlight this. A horizontal line means the body has stopped moving, so it has a velocity of 0 meters per second. But that's just the explanation of why that is. Anytime you see a horizontal line, you can just assume if this is a displacement time graph, on a displacement time graph, a horizontal line represents a velocity of 0. Okay, this example says a man drives 10 kilometers in the same direction to work in 2 hours. He remains there for 3 hours before returning home to have his lunch. The return journey takes 30 minutes, and it says draw a displacement time graph showing his journey and calculate his average speed. And then it also says what distance has he traveled, and then what is his overall displacement. So what we're going to do in this question is we're going to draw a displacement time graph out to help us, and then we'll see what we can do with it. Okay, you can see I've drawn out the displacement time graph here. Well, part of it, I just need to fill it in. It says, so let's just go through it and look at what is happening. It says, man drives 10 kilometers in the same direction to work in 2 hours. So 2 hours is here and 10 kilometers is going to be here. So I'm just going to link it up, and you would obviously use your ruler to do that. I'm sort of doing this freehand. That's fine. So there's what we have. He's gone 2 hours. He has gone 10 kilometers. So he stays in work for 3 hours. So that means his velocity is 0. His speed is 0. So he's just as a horizontal line. Believe it or not, that's a horizontal line. And then he returns. His return journey takes 30 minutes. So his return journey is not going to be up this way. Return journey has to get him back to the start. So it's going to be down from here down to here. So just link it up as best as I can. Dear me. There we are. We can see very roughly that's what's going on. Okay. What the question says is draw a displacement time graph showing his journey. You do that with a ruler, obviously. And what distance has he travelled? Okay, so the total distance, he's gone 10 kilometers out to work. He stays in work for a bit, and then he comes 10 kilometers back. So his total distance, first of all, total distance is equal to 10 plus 10, which is just 20 kilometers. Next part says calculate his average speed. So average speed is equal to total distance divided by total time. Okay, so it seems a wee bit unfair because he's just sitting in his office for a while, so he's not actually traveling. But his total distance we've just worked out is 20. His total time is 5.5. So if you do 20 divided by 5.5, what you're going to get is going to be 3.64 kilometers per hour. Remember, our distance was in kilometers, or our time was in hours, and that's going to be to 2 decimal places. The last thing asked me for his total displacement. So total displacement, remember, is relative to where a certain point. So his displacement is relative to where he starts in this case. So he's gone out 10 meters, or 10 kilometers I should say, but then he's come back 10 kilometers. So where he is relative to where he started, he's in the same place. So his displacement is 0 kilometers. And that is it.